So today we'll be discussing about the ordinary Portland cement. So we'll begin with the composition and manufacturing. So in raw materials, first we have limestone, which is calcium carbonate. Then we have clay or shale, which is silicon, aluminum and iron oxides. Then we have gypsum, that is calcium sulfate. Then in the manufacturing process, the first step is quarrying, which means extraction of raw materials from quarries. Then we have crushing. So the extracted raw materials from quarries are crushed into smaller pieces. Then we have blending and grinding. So the raw materials which are collected from the quarries and crushed into smaller pieces are now mixed in correct proportion and ground into a fine powder, which is called as raw meal. Then we have preheating. So the raw meal is preheated using hot gases from the kiln. Then we have clinker production. So the raw meal is heated in a rotary kiln at about 150 degrees centigrade to form clinker nodules. Then these clinker nodules are rapidly cooled to preserve the reactive properties. So the reactive properties of the composition of the OPC are preserved by rapidly cooling it from 1450 degrees centigrade. Then final step is grinding, which means the clinker is ground with gypsum to produce the fine powder known as ordinary Portland cement. So the final ordinary Portland cement is now formed. Then we have the types and grades. So the different grades of OPC are OPC 33 grade, OPC 43 grade, OPC 53 grade. So OPC 33 grade means the minimum compressive strength after 28 days is 33 MPa, and 43 grade the minimum compressive strength is 43 MPa after 28 days, and similarly after 28 days OPC 53 is the compressive strength is around 53 MPa. Then we have some properties. We have the physical properties. In physical properties we have fineness. So fineness of the cement determines the rate of hydration and the strength development. Then we have the setting time. So the setting time of the cement is divided into initial and final setting time. Then we know about the soundness. So it ensures volume stability and prevents expansion. So good sound cement ensures volume stability and prevents expansion. Then we have the compressive strength. So it is the key indicator of performance measured at different intervals, that is 3, 7 and 28 days. Then the consistency. So this consistency, it is a measure of the water content required for a workable paste. Then specific gravity. So it is typically around 3.15. So then we have certain chemical properties. So in first we have the calcium silicates, that is C3S and C2S. So it contributes to strength development. Then we have tricalcium aluminate, C3A. So it influences the setting time and the sulfate resistance. Then we have tetracalcium aluminoferrite, C4AF. It impacts the color and contributes to strength. Then we have gypsum. It controls the setting time by slowing down the hydration of C3A. Then certain applications. In general construction, it is used in residential, commercial and industrial building projects. Then in structural applications, it is used in reinforced concrete in beams, columns, slabs and footings. Then in precast concrete, it is used in elements like pipes, blocks and panels. Then for certain infrastructure projects like roads and highways, it is used in pavements, bridges and flyovers. Then under dams and reservoirs, it is used where water retention and control structures are required. In marine structures, it is used in ports, piers and seawalls. Then we have some special applications like it is used in the mortar for bricklaying and plastering. Then in foundation, it is used in strong and stable bases for building and structures. Then in tunnels and subways, it is used as a structural element and lining. So what are the advantages of the ordinary Portland cement? High strength, durability, versatility, workability and availability. So under high strength, it is suitable for high load applications. Durability, long lasting and resistance to weathering. Then in versatility, it is used in wide range of construction projects. Then workability, good plasticity and ease of handling. Availability, it is widely available and produced globally. Then we have certain disadvantages. High CO2 emission during production. Then potential for shrinkage if not properly cured. Then OPC is susceptible to sulfate attack in aggressive environment unless modified. Then under curing, so a proper curing is essential to ensure the development of strength and durability in OPC concrete. So curing involves maintaining adequate moisture, temperature and time to allow the cement to hydrate fully. Then the standards and specifications. OPC is manufactured and tested according to various national and international standards such as ASTM C150 American Standard for Portland Cement, BSEN 197-1 European Standard for Common Cements. Then we have IS 269, that is the Indian Standard for OPC. Then certain innovations and modifications. Blended cements, incorporation of supplementary cementitious materials like fly ash, slag and silica fume to enhance properties and reduce environmental impact. Then we have high performance concrete, which uses OPC with admixtures to achieve superior performance. Then environmental considerations. So during the production of the OPC, high energy is required for the clinker production. Then it is a significant source of global carbon dioxide emission. Then the use of alternative fuels, raw materials and carbon capture technologies to reduce the environmental footprint. So ordinary Portland cement remains a cornerstone of modern construction, valued for its reliability, strength and versatility. Despite its environmental challenges, ongoing innovations and sustainable practices aim to mitigate its impact while continuing to support global infrastructure development.
It is a type of blended cement that incorporates granulated blast furnace slag with Portland cement clinker and gypsum. This type of cement is known for its durability, sustainability and improved performance in various applications. Composition and manufacturing. Clinker 50 to 70%. This is the primary ingredient similar to OPC produced by heating limestone and clay. Then granulated blast furnace slag 25 to 70%. It is a byproduct from the iron and steel industry providing additional cementitious properties. Then we have gypsum 3 to 5%, which is added to control the setting time of the cement. So in composition we have clinker, granulated blast furnace slag and gypsum. Then in properties, the first properties is strength. So this Portland slag cement develops strength slower than OPC but reaches comparable strength over a longer period of time. So it takes time but it reaches to the extreme strength during a longer period. Then the long-term strength is higher than OPC due to continued hydration of slag over the time. Then durability. First is chemical resistance. The enhanced resistance to sulfate attack, chloride ingress and alkali silica reaction, making it suitable for harsh environment. Then water tightness. It is improved due to the dense microstructure reducing permeability. Then workability. Generally better workability and pumpability due to the fine particles of slag which improve the mix consistency. Heat of hydration. Lower heat of hydration as compared to OPC, which reduces the risk of thermal cracking in large concrete pores. What are the advantages of Portland slag cement? Sustainability. It utilizes industrial byproducts, that is slag, reducing environmental impact and conserving natural resources. Enhanced durability. It has better resistance to environmental and chemical attacks, leading to longer lasting structures. Then we have lower carbon footprint. So reduced clinker content leads to lower carbon dioxide emissions during production. Economical. It is often more cost effective than OPC due to the use of slag. So these are the 4 advantages from PSC. Then disadvantages. The early strength. The slower development of early strength, which may be a drawback in projects required rapid strength gain. So those projects which required rapid strength gain, they should not use Portland slag cement. Setting time. The longer setting time as compared to OPC. Cold weather construction. So it is less suitable for use in very cold climates where rapid strength development is necessary. So what are the applications of Portland slag cement? Marine structure. It is ideal for coastal and marine construction due to its high resistance to chloride and sulfate attacks. Mass concrete works. It is suitable for dams, foundation and large concrete structure due to its low heat of hydration. Then it is widely used in building construction for its durability and cost effectiveness. Then it is also used in construction of highways and bridges due to its long-term strength and durability. Then comparison with OPC. In composition, PSC includes granulated blast furnace slag in addition to clinker and gypsum, whereas OPC consists of only clinker and gypsum. In strength development, PSC gains strength slower than OPC initially but achieves higher long-term strength. Durability. PSC offers better resistance to chemical attacks and lower permeability than OPC. Environmental impact. PSC is more environmental friendly due to lower clinker content and the use of industrial byproduct. So what are the relevant standards and codes? IS 455 Indian Standard Code for Portland slag cement specification, ASTM C595 American Standard for blended hydraulic cements including PSC, EN 17971 European Standard for cement, which includes specifications for
the Portland Pozzolana Cement (PPC) is a type of blended cement which is manufactured by grinding ordinary Portland cement clinker, gypsum and pozzolanic materials. The pozzolanic materials include fly ash, volcanic ash, calcined clay or silica fumes which enhance the properties of the cement and make it suitable for various applications. First of all, the composition and manufacturing of Portland Pozzolana cement.
So clinker 60 to 70%. It is the primary ingredient which is produced by heating limestone and clay. Then we have gypsum 3 to 5%, which is added to regulate the setting time of the cement. Then the pozzolanic materials around 20 to 30%. So these are typically fly ash or volcanic ash, which reacts with calcium hydroxide in the presence of water to form compounds possessing cementitious properties. Then properties. First of all, the strength. So the PPC gains strength slowly but achieves similar or better final strength compared to OPC. Then higher the OPC due to continued pozzolanic reaction. So it will have early strength and it will have a long term strength. Then durability. Under durability we have chemical resistance, increased resistance to sulfate attack, chloride penetration and alkali aggregate reaction due to reduced permeability. So PPC has very less permeability, so it is having good resistance towards sulfate, chloride and alkali. Then water tightness. So PPC is enhanced due to the dense and refined microstructure, so it is water tight. Then under workability, so PPC is improved due to the finer particles of pozzolana, which will fill the voids in the concrete mixture, providing better workability and pumpability. Then it will have a lower heat of hydration compared to OPC, which reduces the risk of thermal cracks in large concrete structures. Then we come to the advantages of Portland Pozzolana cement. First of all, economical. The use of industrial byproducts like fly ash reduces the cost of production. Then environmental benefits. It utilizes waste products, reducing the environmental impact and conserving natural resources. Then enhanced durability. So it has a better resistance to various environmental attacks, leading to longer lasting structures. Then lower carbon footprint. So PPC have a reduced clinker content, which leads to lower carbon dioxide emission during production. So then we have the disadvantages. Early strength, which means the slower development of early strength, which can be a drawback in the fast-paced construction projects. So nowadays the construction projects are in a very faster rate. So this cement has a slower development of the early strength. So it may be a drawback if you are considering the fast-paced construction projects. Then setting time. It has a slightly longer initial and final setting time compared to OPC. Cold weather construction. It is not ideal for use in cold weather conditions due to slower strength grain. Then we have the applications. So PPC is suitable for dams, bridges and other large concrete structures due to its lower heat of hydration. It is also used in coastal and marine construction due to its improved resistance to sulfate and chloride attacks. And it is also used in building construction for its durability and cost effectiveness. It is also ideal for sewage treatment plants, water tanks and retaining walls due to its water resistance properties. So for lower heat of hydration, it is used in dams, bridges and other large concrete structures. For its sulfate and chloride resistance, it is used in coastal and marine construction, and for its durability and cost effectiveness, it is used in building construction, residential buildings, and because of its water resistance property, it is ideal for sewage treatment plants. So in comparison with OPC, so OPC is made from clinker and gypsum only, while PPC includes pozzolanic materials. OPC provides higher early strength but similar long-term strength is compared to PPC. PPC is more durable due to its enhanced resistance to environmental attacks. PPC is more economical and environmental friendly due to the use of industrial byproducts. Then we have certain relevant standards and codes. IS 1489 Part 1 Indian Standard Code for Portland Pozzolana Cement specification using fly ash. Then we have IS 1489 Part 2 Indian Standard Code for Portland Pozzolana Cement specification using calcined clay. Then so understanding PPC cement in detail, including its composition, properties, advantages, disadvantages, application and standard is crucial for competitive exam in fields such as civil engineering,